Hello and welcome back. This is video number 4 for the Meyer Sound MAPP 3D tutorial number 3, assignment number 3 for the Speaker Systems Design and Optimization course at Husson University. Students, this is for you, and those of you out on the web, you are welcome too to follow along and articulate a line array. In the last video, we angled the array, and now we're going to move on and do some other steps. First thing I'm going to do is save a new version. And here we go, save as, add a new version here so I can come back to it in case there is a problem. And the next thing is, as you get into like doing predictions here, especially when you get into larger venues, sometimes the predictions can take a while. You sit here and wait and watch status bar. Steps you can take to make Meyer MAPP go faster. Definitely use separate layers. Thing we've done here, we've got the prediction planes on separate layers. We have the CAD drawing, that's the DXF here. It is on its own layer, and I separate different loudspeaker elements on different layers. And this makes it easier so that you can hide the balcony. If you're just working downstairs, you can hide the balcony, and then you don't have to wait for it to get predicted. So when you have larger venues, you can hide sections of the venues that you don't want. Or you can hide speaker systems. You don't want to see what the subs are doing, therefore you don't have to wait and see how the subs are going to... If you're only doing high frequencies, turn off the subs, hide the subs. So hide things you're not using, put things on different planes. And here's a big one, lock your layers that have prediction planes. The program goes faster when you lock your layers. And there is one other thing here, and I'm not convinced this ever makes much of a difference, but if you go to project settings, which is under File, Command-Shift-P, you can actually, under, where is it? I've forgotten, Appearance. You can change your mesh density, and higher resolutions predict slower, at least the first time you predict. So you can speed up MAPP a little bit by messing with that, okay? So those are just some tips I wanted to add here. Going forward from that, let's get the loudspeaker processor working. Here in Husson University, we have an older Galileo processor, and the MAPP unit, the processor that defaults here in MAPP 3D is the Galaxy, the current processor. So I'm going to delete the processor. You can delete the default one, delete the Galaxy. So we'll just hit delete. And it's going to futz up our arrays because our arrays were assigned to it. And to make a new processor, you go under Tools, Signal Processor Management. And I could have done the deletion through here as well. I'm going to add a processor. And this time I'm going to add a Galileo, because that's what we have. We have a 616 at Gracie, and I believe you're supposed to name it the Gracie Galileo for the assignment. And so if you're into following the instructions, you can insert the name there. So now we have a Galileo processor, and the next step is to I got a typo there. I'm going to fix it. Sorry. Next step is we're going to assign Galileo processor channels to our array. So let's go to our array. We can just grab it and then go to Object Settings, and we can look at our array. And you can see they have lost their assignments. All the 10 channels of the array, the 10 boxes, they are not assigned to a processor anymore because I deleted the Galaxy. So you want to put them all on the Gracie Galileo. So you got to kind of click through here. You might be able to, well, let's just do this. So had I created the Galileo before I had created the line array, it may have automatically assigned it to that because that's what it did before. But this isn't too much work, right? You just got to do this one time here and make sure they are all going to assign to the Galileo, all 10 channels, and that's done. Now, the next thing is you need to assign these boxes to different channels, and there are some situations, and we will play with this later in the semester, where you want each box on its own drive line, on its own channel, so you can do things like LMBC, low frequency beam steering, or other types of interesting shading. In this situation, at the Gracie, because we have a 16 output processor, and we have a left array and a right array and a bunch of subs and front fills, there are only 4 channels free per array. So I want you to follow the assignment here where the top 2 boxes go to channel 1, then boxes 3, 4, 5 go to channel 2, then 6, 7, 8 go to channel 3, and the bottom boxes 9 and 10 go to the 4th channel. So in this case, it's like top box 1 and 2. Of course, I am in the processor settings right now. I'm naming these array channels. Then it's going to be boxes 3, 4, 5. Then it's going to be boxes 6, 7, 8. And then the bottom box, BTM here, bottom box is box 9 and 10. So I've named these channels. So now when I go back to model view and I select my array, it's still selected, and go to objects view, it'll be easier to assign the top boxes. And by the way, there is a way to assign multiple channels at once. When you're doing an array where you want every channel to go to a different output, it's very useful to use this kind of multi-assign button here, and then you can assign multiple channels to cascade across multiple outputs all at once. It makes it go a lot faster than having to manually assign it. It just did it for me, but I didn't want it to. Because, in fact, in this particular situation, it's just easiest to do it by hand. But in other situations, you'll definitely want to use that multi-assign. In this situation, we want 1 and 2, then 3, 4, and 5 for the next 3 ones. Then the next 3 ones are going to be 6, 7, and 8. And then the bottom 2, the last channels of the array, are going to go to 9 and 10. So this is a output box 9 and 10. There we go. So there we have now assigned them all to the correct outputs, which makes it a lot easier to process them, which we're going to do in a second here. Okay, so that's been done. I talked about multi-assign in the instructions. Really useful to use multi-assign, but generally not needed. Great. So now let's take this array, which we've articulated it, and let's copy it and make a right array. And that's very simple. Use the mirror tool up here, the upper right, and you want to mirror along the y-axis. And so it copies it to the same location, but the y-axis is now positive, it's negative. I do object settings. You'll now see it is a positive 19, where the other array was a minus 19 feet. The one catch here is that we want to put this on another layer. So let's add a mains right layer, so you can hide the array when necessary. And we need, with it selected, we're going to go up to object settings and take this mains right, and I'm going to call it right mains or mains right. So I've just named the array, and I want to assign it to the right layer. That's the layer select. So now we have put that in its own layer, and I can hide it as necessary. That didn't quite work that time, did it? Sometimes Mac's a little buggy like that, which is all this means. It's probably a good time to save. Is there anything I missed here? Of course, the challenge here is that you pretty much don't want to mirror the arrays until you're done angling, because it's a real pain in the butt to have to change the angles in 2 arrays. So if you do decide you want to change angles, basically delete that second array, do your angles again on the first array, and then use that mirror tool if you want to bring it back. So let's save, of course. Always save your project. And I'm on like version 4. I know this might seem excessive, but boy, I've had problems with map crashing. And we'll pick up here on the next video. All right? See you in a minute. Bye-bye.